So again, good afternoon to everyone. So today I'm going to share to you a study done in Davao City. As in comparison to the presentation given to us by Engineer Tinoy, this study would mostly talk about simulations in Davao City for two sites. Now, the thing with simulation is that we're trying to capture or simulate accurately or near accurately some of the scenarios or phenomena that's happening in a certain study site. Uh, the reason for that is for us to understand what is happening, and also for us to identify the sources of the phenomena, and finally for us to come up with a mitigation strategies in order to solve the problem. Now, just a quick recap of what Engineer Myla Inoy discussed a while ago. She discussed about the urban heat phenomenon in Davao City, in which she discussed that there is already an evidence, or it is already evident that Davao City is developing urban heat island. This was proven through the use of satellite images, such as the land surface temperature images, and also some of the air temperatures that was taken uh, during their field work. She also correlated some of the she also correlated some of her studies with other social factors such as energy consumptions, and also conducted thermal comfort survey. Now, for today, again, this study is a summary of simulations. There might be some skipping of the methodology because of the long discussion for that, but we encourage everyone uh, to watch out for the full report which will be given at the end of the project. So this is a simulation. This is the presentation outline for my study. First, we're just going to do a quick overview of what is urban microsimulation. Then we will go directly uh, to the results that we had when we simulated two areas in Davao City, specifically Davao City Hall Complex and also the Claveria Street or the CM Recto Street. Now, we place different scenarios for those different sites, such as determining the cooling effects of green roofs, and also determining what are the possible scenarios when we place buildings or we place trees in island centers. Now, if some of you have attended the national webinar last July 17, we discussed about, in background, what is urban meteorology and what is in urban areas that seems to affect urban weather and climate. Now, because of urbanization, there is an alteration or there is a change in the natural landscape, and features that are usually man-made are implemented, which affects the urban weather or climate. Now, what are these urban features that affects the weather and climate? Some of the examples are release of pollutants from industrial and power plant sites, our street geometry, such as our street canyons, building distributions, anthropogenic heat, emissions due to human activities such as the exhaust that we get from diesel engines, from our transportation, or also um, building heating or cooling systems or air conditioning systems. Now, uh, there are also impervious materials that we use for our roads, such as asphalt or concrete, which alters urban weather climate. And lastly, the building morphology. This is more on the architectural side, such as the building size, shape, height, or the number of stories. Now, when we put all of these features together, this contributes our urban setting, which affects the urban weather and climate. Now, in modeling or simulating real-life phenomena, we integrate all of these features into a model for us to come up with a near accurate scenario of our study site. Now, this is a map of the urban atmosphere, wherein we have the mesoscale level and also the microscale level. For the mesoscale level, usually this is in terms of horizontal extent. It is usually at 1 kilometer or more, sometimes extending to 25 or 100 kilometer. Now, when we do mesoscaling in urban simulation, it usually encompasses the entire region or the entire city. Now, take notice of the written features here, which we mentioned a while ago, such as the urban features we mentioned a while ago. All of this actually contributes to the alteration of our urban weather or climate. Now, it's very important to point out is that because of these urban features, these are actually unique per city. We cannot make a generalization that the urban features of Metro Manila might have the same effect in terms of urban weather in Davao City. That's why we create simulation, contextualize it, or localize it. Now, in a microscale level, which is our focus for right now, the extent or the domain of our simulation is usually at around or less than a kilometer. That could be in terms of block or just by streets or just encompasses around certain buildings or such. Now, if we take into consideration the microscale level, which I will zoom right now, these are some of the urban features I have mentioned a while ago. Now, how do these urban features affect our urban atmospheres? For example, the materials that we use for our building, sometimes it has low albedo, or meaning it has low reflectance materials. Instead of reflecting solar radiation, it tends to absorb it. We have insulated surfaces that leads to high surface temperatures, or we have limited sky view, which traps heat within buildings. And the other one is that, for example, anthropogenic heat sources from our cars, impermeable surfaces from the roads, and also how we place buildings together. It affects the wind because wind actually helps in convecting or dispersing warm air, but because of the placement of our buildings or our structures, sometimes it causes turbulent winds or it traps warm air. The thing with turbulent wind is that if wind or if the area has turbulent wind, the tendency it has also a higher air temperature. Now, given this microscale that we have, we try to model all of this together to come up with a real or near accurate real life scenario. So here comes the model that we use, NVMet. So NVMet is a microclimate simulation software which we use to simulate urban environment. And it can also assist environmental planning in terms of like creating new towns or possibly simulating new buildings or simulating new construction materials. And it also create microclimate simulations so that we can plan out resilient cities and in the context of our project without urban heat islands. So the simulation that we will be presenting today mostly covers the use of NVMet. Moving forward, here is our simulation scenario with our sites. First is in Davao City Hall complex, wherein we determine the effect of green roofs if it cools our air temperature. Second is we determine or we analyze what are the effects of in terms of air temperature, considering proposed scenarios such as construction of a new condotel or the new skyway in Claveria Street. So for our first study, this is Davao City Hall complex. It is around 150, 970 square meter. And it has two roads, main thoroughfare natin, which is San Pedro Street and Magallanes Street. Now, for those people that are not familiar with this setup, these are the landmarks that we have. So we have the City Hall, Sangguniang Pansod, Cathedral, the Rotunda, and such. So this is the real photo, and also this is in terms of the NV model. This is how we modeled it. Now, what are the scenarios that we have? So the scenarios that we have is that we have the current scenario, followed by scenario 2, which is the current, we add green roofs. The third is we add buildings. So we add buildings on the areas where there are spaces. And the last is the buildings wherein we place from scenario 3 and we place it with green roofs. Now you may be asking, how do we qualify the green roof part? So what we did is that we conducted a survey, and what we consider or criteria for placing the green roofs are first, it should be concrete. Second, it should be a flat surface instead of blind. And third, those two qualifications. So this is just a spatial distribution of our air temperature. So we chose actually the 9 a.m. One morning, one after mid-afternoon, and noon, and the other one is the morning. So what this figure shows to us is that this is an air temperature simulation taken at 2 meters, and generally this air temperature ranges from 25 to 41 degrees Celsius. And as you can see here, in this case, we notice that most of the hottest part is around 1 p.m. Now we will try to look at it scenario by scenario, comparing it with the current scenario. Now this is scenario for scenario 1, and for scenario 2. So we notice a higher temperature for both scenarios at 1 p.m. But in comparison to scenario 1, we see that the air temperature for scenario 2, which is with green roofs, it is lower compared to scenario 1 at 1 p.m. Now, what this actually tells us is that the placement of green roofs contributes to the lowering of air temperature. Now, the air temperature, lowering of air temperature is seen from 9 o'clock, 1 p.m. and 5 p.m. In scenario 3, wherein we place more buildings in areas that are previously open space in scenario 1, we see a similarity of temperature, and we see it evident. And evidently, we see the air temperature on the streets. So we see that the air temperature colors here are almost the same when we place more buildings in the area. Whereas, what if with the buildings that we place in scenario 3, we put green roofs on top of it, we see or we observe a slight reduction, which means that in comparison to open area plus the green roof, this one, even if you put green roofs with more buildings, the air temperature is slightly lower from the scenario 1. So which means that in terms of mitigating strategies, placing more buildings is not contributes to warming the air temperature at near surface level, even if we put green roofs. Now this is a figure of the hotspot or the evolution of hotspots, and we focus on at around 1 p.m. because this is at this time that the hotspots are larger in terms of area. So looking at this hotspots, we see hotspots developing in certain places, but it has some similarity. So we will try to look at one by one. For example, in this case, in City Hall, we see that the hotspots are usually located in open areas. This one is between the cathedral and the Sunian, and it is located in the streets, especially area where there is asphalt road, and also in the Rotunda area. So it's in the Osmeña Park and also the Rotunda area. Now, when we place green roofs, we see a reduction in the area of hotspot. And so going back now, this is the evolution of the hotspot air temperature at the hottest time, which is around 1 p.m. So as you can see, we have the current scenario, the current but green roofs, the more buildings in scenario 3 and the more buildings with green roofs. Again, as I mentioned a while ago, we see actually a reduction of our hotspots from scenario to scenario. But then the difference between this one is that for scenario 2, the reduction of hotspot is because of the addition of the green roofs. While on the other hand, in scenario 3, there was a reduction of the observed hotspot because we placed buildings. Now, that's kind of impossible for hotspot area to occupy the same area in the current situation because buildings are already placed. But one thing that is similar is that we still see the same hotspots in the area of Rotunda. And also, when we go to scenario 4, when there are more buildings but with few green roofs, we still observe the same areas of hotspots. Now, you might be thinking scenario 3 and scenario 4, I mean, what's the difference with this one in comparison to scenario 1? You see the color gradient on the left side of the figures, we see that in comparison to scenario 1, the air temperature usually located in the streets, on the streets, it's much, not much, but a little bit cooler compared to scenario 1. But then we can see a more evident cooler air temperature for scenario 2 in comparison to scenario 1. Next slide, please. So this actually tells us a graph of the mean hourly air temperature, wherein we see we see the diurnal air temperature for this graph by scenario. So immediately we can observe that for scenario there is a lower air temperature, especially at during peak times. As mentioned a while ago, air temperature peaks at around 12 noon to 1 p.m. to 2 p.m. But then we observed that when we place green roofs on top of the buildings, we see that there is a lower air temperature compared to scenario 1, 3, and 4. Now, to further quantify this, we actually took difference or the mean difference. Now, we see that when we use the scenario 2 with green roofs, we see that the difference in air temperature is 2.15, meaning that scenario 2 is cooler by around 2.15 degrees Celsius. While on the other hand, if we use scenario 3 and 4, we see it's around 0.26 and 0.30 respectively. Again, we see a contribution for 3 and 4, but it's actually quite smaller compared to scenario 2. Now, to determine what is the effect of green roofs, when we place it at a certain height level, at near surface level, we also took it by height. Next slide, please. So what this graph tells us in terms of our mean observation 9, 1 p.m. and 5 p.m. is that when we place green roofs, which is seen in the yellow bar chart graph, we see that it's more effective compared to scenario 3 and 4 in lowering the air temperature around the complex of Davao City Hall. Okay, so we move further. All right, so this is what we meant a while ago. We try to determine or gusto natin malaman, for example, kung maglalagay ba tayo ng greenery sa roof natin, ano kayang epekto nito kapag nasa 2 meters? Kasi yun yung interest natin eh, kasi natin nararamdaman yung air temperature. So moving forward. So in this study, we try to determine the impact of vegetation and also the building shading. So as you can see here, we take temperature at 2 meters and at 11 meters. All right, moving, please, next slide. Okay. So this graph tells us that it's a difference of the air temperature, building roof level, and also the near surface level. The negative values for this graph indicates that mas warmer ang near surface natin or kung saan natin nararamdaman. On the other hand, positive values shows to us that mas malamig ang near surface level. So immediately we can see for scenario 1, the current scenario, we see that pag walang modification, we see that the near surface level is warmer or mas mainit siya. But if we try to incorporate certain scenarios, for example, in scenario 2, it's quite the opposite or inverse of what we see in scenario 1. Placing green roofs actually contributed to the cooling of near surface at 2 meters air temperature. But then, looking at scenarios 3 and 4, which looks almost the same, in this case, wherein we place taller buildings, we see that even if we put green roofs sa taller building, konti lang kanyang contribution in terms of cooling at 2 meter levels, as you can see here. Now, what does this actually imply? This implies that true that there is a lowering of air temperature in building roof in near surface level when we place green roofs in building roof level, but the catch here is it depends actually on the height. The more that your building is, or you have skyrise building, even if you place green roofs on top of it, actually, konti lang yung kanyang epekto pagdating sa 2 meters level in comparison to mga buildings that are, let's say, 1-story or 2-story. So again, this is not a generalization, but this is what we found out sa study na to, and this can still be replicated. All right, next. I'll proceed further. Okay, so the next scenario we have is in Claveria Street or the CM Recto. It's around 631,308.55 square square meter. And this is actually an area or thoroughfare where it experiences heavy traffic due to private and public utility vehicles. There are few trees but with partially covered walkway. So in this area kasi sa NVMet, to simulate this big area would really be quite big use or is heavy computationally. So that's why we divided it into sub areas. So we have sub area 1, 2, 3, and 4 as seen in this figure. Moving forward. All right, so next slide, please. So these are the model scenario for the entire sub-area. So we have 3 scenarios. First is the current situation. Second is more buildings. We place the buildings in areas that are still open. And the next is we place randomly green roofs in the sub-area, and we also place center island. We place plants in center island. So this is reflected in all sub-areas. So when we move further, so I'll make this faster. Okay, sige, please move forward. Next slide, please. All right, sige pa. All right, so dito na. So in this case, kasi there are some ongoing construction or there are future developments according to the local government of Davao. We place in sub-area 2, we have the Condotel. While in Rojas Sky Garden, we have the, in sub-area 3, we have the Rojas Sky Garden. On the other hand, sub-area 1 and sub-area 4, we randomly assign buildings. Okay, can we move forward? So here are some of the initialization in terms of placing trees in center islands and also the green roofs, some among grass sa green roofs natin. Okay, so sige. All right. So this is the spatial distribution of hourly air temperature for scenario 1, 2, and 3 for the for area 1. To summarize what we see here is that again, this from 4 o'clock to for until 6 p.m. But again, what we can observe from this figure is that when we place green roofs and center islands with trees, we see a lowering of air temperature. As compared to less trees, more buildings, and also with the current scenario. Now, this is reflected in all sub-areas. Moving forward, in sub-area 2. All right, next slide, please. Yes, we observe the same characteristic, lower air temperature for areas with green roofs and center island. This is also for sub-area 3 and also sub-area 4 for the next slide. Now, in the same way what we have done a while ago, we try to zoom in on certain times at 9 a.m. All right, sige, next slide. At 9 a.m., 1 p.m., and also at 5 p.m. So in this case, we see air temperatures for this time steps. Now, what we see here is that this is actually quite of interest because this is not affected for this sub-area because supposedly what we expect for sub-area 1, the green roofs and center island with trees should supposedly contribute to the lowering of air temperature. But that is not what we found out or what we see. This could be because of some additional addition of factors that we have not included. But then, looking at sub-area 2, 3, and 4, moving forward, please, we see that green roofs and center island with trees lowering the air temperature in comparison to your current area. So, for example, in this 1 p.m., we can see evidently. Okay, so previous slide. So we can see that the air temperature in this case is lower compared to scenario 1 in sub-area 2, 3, and 4. But for sub-area 1, the opposite happens wherein the green roofs with center island with trees has higher air temperature. So again, for further recommendation that needs to be studied, wherein we incorporate more details and field work, determining what are the actual condition of sub-area 1. Now we focus on the hotspots. We move forward. So in this case, you see a hotspots developing in certain areas, but usually, mostly this is located sa lower part. So in this case, as you can see in scenario 1, we see a concentrated areas of hotspot. But when we go to scenario 2 and 3, we see a reduction of the hotspot in comparison to scenario 1. But then again, we try to look at the color gradient of the entire map. As in the left figure, we see that there is a, the one that I mentioned to you that is of quite interest. We see that the air temperature scenario 3 is above, slightly above than the area, than the temperature in sub-area 1. But then the opposite is seen for sub-area 2, 3, and 4. Move forward, please. Yes, for example, in this case, we see that sub-area 2, scenario 3 has lowered air temperature. Sub-area 4 has lowered air temperature as well. And sub-area 2, all right. All right, so we see that for sub-area 1, which is quite opposite, but for sub-area 2, 3, and 4, we see a contribution in lowering the air temperature for green roofs and center island. Now, to further sum this one, we're almost at the end of presentation. So this is what we meant a while ago for the air temperature. The blue one that we see in sub-area 1 is the one that we saw na mas mababa mas mainit yung air temperature. Yung red at saka yung green kaysa compared dun sa blue, which is the current scenario. Now, looking at sub-area 2, 3, and 4, we integrated yung green roofs and more buildings. Although we observed a while ago na in terms of the color map, meron siyang merong contribution in terms of cooling the air. But then in terms of this hourly air temperature mean, we see na the difference between the current and also the different scenarios are maliit lang. Now, what we see here is that there might be low contribution of lowering air temperature when we place the greeneries. Now, what we suggest or what we found out is that, or for further recommendation is, we need to do a further simulation because we only consider green roofs. So what if we consider other mitigation strategies such as vertical greening or replacing the pavements with cooler pavements and such. So doing that studies would actually allow us to determine more if mas effective yung ganong strategies in comparison to putting trees at the center island and also the green roof. Now, in summary, right? So, sige, move forward. All right. In summary, major findings from the study is that when we put green roofs, it actually depends on the height of the building. If you have a sky-rise building na masyadong mataas, let's say 5-6 story buildings, placing green roofs might be of lower contribution in lowering the air temperature at 2-meter level, if that is the purpose. But then we know that using green roofs has other purposes such as cooling capacity, decreasing energy consumption. But if the purpose is for decreasing urban temperature or near surface temperature, hindi gaano effective yung greeneries or rooftop greeneries. Now, what we suggest or recommend is that we can actually place vertical greenings since it covers at different height levels. And lastly, our recommendation is that we try to incorporate different mitigating strategies, not only one, such as green roofs or center island trees, but also incorporating what if we change the materials, or what if we place vertical greenings, or we place cool pavements in the area. That might be of help in terms of decreasing the air temperature. Sure. So for further discussion about this topic or the results that we got, a separate paper would be released, and you can actually just post your questions in the question and answer, and we will try our best to answer all of those. So thank you so much for listening. Apologies for the technical interruption. Thank you so much.